Very good morning, dear students. Today's our video is on modulus inequalities problems. We are going to discuss many interesting problems, and for the concepts, already we posted one video on modulus inequalities in the YouTube channel. You please refer to that channel and write the notes and do the problems clearly. On part of this, today's first problem is solve minus 1 by mod x minus 2 greater than or equal to 1, where x is not equal to plus or minus 2, because this should not be 0. Okay, the denominator mod x minus 2 will not be 0. If it is 0, then it becomes undefined and the problem itself is not defined properly. Now, for solving this problem, you take mod x is equal to y. Now your problem reduces to minus 1 by y minus 2 is greater than or equal to 1, like this. Now minus 1 by y minus 2 minus 1 greater than or equal to 0, like this. Now let us take LCM, my dear students. Here, if you take LCM here, y minus 2 you are having here, minus 1 minus of y minus 2 is greater than or equal to 0. Now this becomes minus 1 minus y plus 2, right, by y minus 2 greater than or equal to 0. Like this we can do this particular problem. Now after getting this, now minus 1 plus 2, that becomes 1 minus y by y minus 2 greater than or equal to 0, right? 1 minus y by y minus 2 greater than or equal to 0. How we will solve this particular problem? Now by multiplying minus sign on both sides, we will get that y minus 1 by y minus 2 lesser than or equal to 0, because by multiplying minus sign on both sides, 1 minus y becomes y minus 1 and the inequality will be reversed. Now y minus 1 into y minus 2 lesser than or equal to 0 you are having. Now what we do is we multiply and divide by y minus 2. Now this is a problem of method of intervals. This is now y minus 2 whole square lesser than or equal to 0, right? Now this problem y minus 1, you have y minus 1 into y minus 2 lesser than or equal to 0 into anything becomes 0. Now y minus 1 into y minus 2 lesser than or equal to 0, we have got this problem. Now after getting y minus 1 into y minus 2 lesser than or equal to 0, my dear students, we know that y values 1 lesser than or equal to y lesser than or equal to 2, like this, right? That means we have 1 lesser than or equal to mod x lesser than or equal to 2. These are the values we have got, right? That means we know that we already did one problem, right? What we did, that problem is like that means x belongs to, right? Actually x belongs to, whenever we are having a lesser than or equal to mod x lesser than or equal to b. I already given one result, okay? That based on that we are going to have that, okay, x belongs to, right? X belongs to here, fine, x belongs to minus 2 to minus 2 to minus 1 union 1 to 2, like this. But we told that here x is not equal to plus or minus 2. That's why what we will take is now minus 2 plus 2 are not included. That's why now this becomes minus 2 open interval minus 1 union 1 is included but 2 is not included. In this way we will be doing this particular problem. Okay, my dear students, this is the way how we do this nice problem, and the result what we used is, if suppose a lesser than or equal to mod x lesser than or equal to b, then we told that x belongs to, right? X belongs to minus b comma minus a union A comma B, like this. This result we used. Okay, this is already discussed in our class. This is the way how we will do this beautiful problem, dear students. The mechanism we totally followed here, the wavy curve method of intervals problem, and once we got this here, this by this result we have got x belongs to closed interval -2 comma -1 union 1 comma 2. But we know that x is not equal to plus or minus 2. Plus 2 minus 2 were not included. That's why we have got the solution set as like this. Now let us do one more problem. Now we have another interesting problem. Solve modulus of 2 by x minus 4 greater than 1, where x is not equal to 4. If x is equal to 4, this problem becomes undefined as you know it. Now how we will do this part of the problem? This modulus of 2 by, okay, this we can write it as modulus of 2 by modulus of x minus 4. We can write this, and it is greater than 1. That means 2 by modulus of x minus 4 is greater than 1. Modulus of 2 is a positive quantity, that's why you will get as it is. Now whenever we can take the reciprocals, then what we are going to have for this event, like even I can write it is by dividing 2 on both sides. We will have 1 by modulus of x minus 4 is greater than 1 by 2, right? By dividing 2 on both sides, because it is a positive quantity, it will be maintained like this. Now you see, my dear students, whenever we are having a greater than b, whenever we have a greater than b, right? Okay, whenever a is greater than b, you see here I am writing here, whenever we are having a greater than b, then 1 by a will be less than 1 by b. It is a very famous property of inequalities. Already we discussed it. By using that fact, we will have modulus of x minus 4 is less than 2. We will get here modulus of x minus 4 is less than 2. That means, my dear students, you know that minus 2 less than x minus 4 less than 2. You know it, because we know whenever modulus of x is less than a, then minus a less than x less than a. By that we are having that thing. Now how we are going to do the x values? We are going to get now the x values, adding 4 on both sides to this, minus 2 plus 4 less than x minus 4 plus 4 less than 2 plus 4, like this. Now this is 2 less than x less than 6. You have got 2 less than x less than 6. And you see, my dear students, that implies that x belongs to 2 to 6, like this. And we know that x is not equal to 4 here. When x is not equal to 4, therefore x values excluding 4, you are going to have 2 comma 4 union 4 comma 6, like this. We are going to, because we excluded 4 value, even that we can write this is same as 2 comma 6 minus that 4 you exclude. This is the solution set we have got beautifully. It's a very simple problem. How we did is modulus of 2 by modulus of x minus 4 greater than 1. That means modulus of 2 is 2, this is greater than 1, and we applied inequalities properties. We have got like this particular problem. Now welcome to the third problem. Solve modulus of x plus 3 plus x by x plus 2 greater than 1. This is a very unique problem. How we are going to solve? You please observe, my dear students, where x is not equal to minus 2. If x is equal to minus 2, then this problem becomes undefined. That's why x is not equal to minus 2. Now you have modulus of x plus 3 plus x by x plus 2, this 1, if you transfer to the left side, minus 1 is greater than 0. Now let us take the LCM. X plus 2 is the LCM. Now you have got modulus of x plus 3 plus x minus of this 1 into x plus 2 greater than 0. Now this becomes modulus of x plus 3 plus x minus 2 by x plus 2 greater than 0. This plus x and minus x will cancel, and we have modulus of x plus 3 minus 2 by x plus 2 greater than 0. Now let us solve this problem in two cases, my dear students. Let us solve this problem in two cases, because we are having modulus of x plus 3. If this is positive, x plus 3 is positive, then what we are going to get the solution set. If it is less than 0, negative, what we are going to get, that is what we are going to deal this particular problem now in two cases, because it is having modulus of x plus 3. Now case 1, let us take case 1 here. Case 1, when modulus of x plus 3 is equal to x plus 3, that means x plus 3 is positive. That means x plus 3 is positive. Modulus of x plus 3 equal to x plus 3. When x plus 3 is positive, you are having like this. In this case, our problem, modulus of x plus 3 become x plus 3 minus 2 by x plus 2 is greater than 0, like this. And also one important thing, my dear students, when x plus 3 is positive, x should be greater than minus 3, because x plus 3 greater than 0 means x is greater than minus 3. That is very, very important. Now this problem reduces to x plus 1 by x plus 2 greater than 0, like this, right? And you know how to do this particular problem. X plus 1 by x plus 2 greater than 0 means, you know that you multiply and divide by x plus 2 for numerator and denominator, and this will be x plus 2 whole square, and that is greater than 0. Now it is positive, we can transfer to the right hand side. Now x plus 1 into x plus 2 greater than 0, right? That means you know that x is less than minus 1, and okay, that means you know that x belongs to minus infinity comma minus 1 union minus right. Here the solution set what you are going to have, right, my dear students? You know that x is less than minus 2 and x is greater than minus 1, like this. You are going to have x is less than minus 2 and x is greater than minus 1. Now we have got, my dear students, x is less than minus 2 and x is greater than minus 1 means minus 2 and minus 1. X is less than minus 2 means minus infinity to minus 2, and x greater than minus 1 means minus 1 to plus infinity you are having here. And one more thing, very, very important information, we told that x is greater than or equal to minus 3. That means x plus 3 greater than or equal to 0. That means x is greater than or equal to minus 3. That condition is supposed to be satisfied. That's why here it is minus 3 and minus 3 is included. That's why it is with full circle. It is greater than or equal to minus 3 means this total solution set you are going to have. Now the common part is the shaded lines here, minus 3 to minus 2, where minus 3 is included, and minus 1 to infinity. That's why x belongs to closed interval minus 3 comma minus 2 union minus 1 to infinity. This is the solution set that you have got in case 1. Now let us going to get the solution set in case 2. You please observe. Now case 2, my dear students, modulus of x plus 3 minus 2 by x plus 2 greater than 0. In case 2, x plus 3 less than 0. When x plus 3 less than 0, x is less than minus 3. And one more thing, modulus of x plus 3 is equal to minus of x plus 3, because mod x is equal to minus x when x is less than 0. In the place of x we are having here x plus 3. Therefore when x plus 3 less than 0, modulus of x plus 3 become minus x plus 3. You have like this. Now let us do our problem. Modulus of x plus 3 become, we have got now minus of x plus 3 minus 2 by x plus 2, that is greater than 0. You have like this. Now this become minus x minus 3 minus 2 by x plus 2. This is greater than 0. Now this is minus x minus 5 by x plus 2 greater than 0, like this, right? Once you have got this thing like this, this we can write it as by multiplying minus sign on both sides. We have x plus 5 by x plus 2 less than 0, like this. Now how we will solve this? You know, x plus 5 into x plus 2, you multiply by wavy curve method of intervals, right? This is you have less than 0, like this, right? and this is whole square. By transferring that side, we will have that x plus 5 into x plus 2 is less than 0 into anything becomes 0. This is what here, x plus 2 whole square, that becomes 0. Now the solution set you are going to have is, my dear students, okay, when it is less than 0, here you have minus 5 and here you have minus 2. Okay, less than 0 means this is included in both, okay, that means okay, open interval minus 5 to 2, and also we told that x is less than minus 3. Here you are going to have between that minus 3, okay, and x is less than minus 3 means this total part we are going to have like this. Now the shaded part, if you take from that, what solution set you are going to get is, in that case, right, x belongs to, right, x belongs to, we have got in case 2, right, minus 5 to minus 2, but we told that there, right, we told that x is less than minus 3. That's why, satisfying these two, we have got that x belongs to minus 5 to minus 3. This is the solution set in the second case. And case 1, we have got another solution set in, okay, these are the solution sets in both cases. This way we will do this beautiful problem, right, my dear students. This is the way how we will do this. Okay, now let us discuss one more problem. Now welcome to very interesting and very important problem of this modulus inequalities. Solve the fourth problem, modulus of x minus 1 plus modulus of x minus 2 greater than or equal to 4. This is a very important problem, my dear students. We will be doing this in a very different way. Please observe with the most okay, interesting. Like, see here the critical points, if you take 1 and 2, the critical points on a real number line, if you take that, these are 1 and 2. This is minus infinity to plus infinity. Now 1 and 2. Now this total real number line is divided into now 3 intervals. One is minus infinity to 1 and 1 to 2 and another one 2 to infinity. In these 3 cases, now we need to answer our solution like this. In these 3 intervals, how will be our solution set? Now case 1, let us take here case 1, when x belongs to minus infinity to 1 like this. This is the interval first we are answering. In this interval, my dear students, what happens to modulus of x minus 1? Here, modulus of x minus 1 is, you see, when x is less than 1. Minus infinity to 1 means what? When x is less than 1. When x is less than 1, you see, this is when x is less than 1. That means, my dear students, x minus 1 less than 0. X less than 1 means x minus 1 less than 0. When x minus 1 less than 0, this is a negative quantity. We are going to take it as minus of x minus 1 like this. Because when x minus 1 less than 0, we know that mod x, we are going to take minus x. In the place of x, you are having x minus 1. That's why it is minus of x minus 1. And okay, in this interval. Next, modulus of x minus 2. Modulus of x minus 2 is also minus of x minus 2, because here when x is less than 1, that implies that x is less than 2 also. That implies x minus 2 here less than 0. X minus 2 less than 0, modulus of x minus 2 become minus of x minus 2. Therefore, your problem now, modulus of x minus 1 plus modulus of x minus 2 greater than or equal to 4, this will become modulus of x minus 1. In this interval, we have got it as minus of x minus 1, that is nothing but 1 minus x, and plus modulus of x minus 2 become minus x minus 2, that becomes 2 minus x, okay, greater than or equal to 4. Now this problem 1 plus 2, that is 3 minus x, okay, let us take 4 this side, and it is greater than or equal to 0, you have got like this. Now you see, my dear students, this is now 3 minus x minus 4. You have got it as like this, that we can write it as 3 minus 4 is minus 1, minus x minus 1 greater than or equal to 0. By multiplying now, by multiplying with negative sign on both sides, you are going to get x plus 1 lesser than or equal to 0. that means x lesser than or equal to minus 1 you have got here like this. Okay, therefore in this case, my dear students, here dear students, one small rectification. Here this is now 1 plus 2, that is 3 minus 2x minus 4 is greater than or equal to 0. Now this becomes, we have got it as 3 minus 4, that is minus 1 minus 2x greater than or equal to 0. That means if you multiply by minus sign on both sides, 1 plus 2x is lesser than or equal to 0. That means 2x is lesser than or equal to minus 1, x is lesser than or equal to minus 1 by 2. Therefore the solution set, my dear students, you have, suppose if you take, now this is now minus infinity to plus infinity, and right, we took the case 1. Case 1 is here 1, you have x less than 1, and here x lesser than or equal to minus 1 by 2, we have like this. Now both solutions are this, now this is included, therefore x belongs to, you have minus infinity to minus 1 by 2 like this, right? Minus infinity to minus 1 by 2, 1 minus 1 by 2 is included. This is the solution set that you are going to get in case 1. How we did it very beautifully, when modulus of x minus 1 become minus of x minus 1 when x is less than 1. That already we discussed, and this is like this. And now take those values, simplify, get that okay, the common solution. This way we will get our solution in case 1. Now this problem in case 2, my dear students, when minus infinity to plus infinity we have here, right? Case 2 is what? Between 1 and 2, between 1 and 2. That means when x belongs to 1 comma 2, that means when x lies between 1 and 2, that means x is greater than 1 and x is less than 2. Now modulus of x minus 1 becomes x minus 1. That means x minus 1 is greater than 0, right? Because modulus of x minus 1 equal to x minus 1, because x minus 1 is greater than 0. Because x minus 1 is positive, mod x minus 1 become x minus 1 as it is, because it is a positive quantity. Now modulus of x minus 2, this becomes minus of x minus 2. That means minus x, 2 minus x, because x minus 2 is less than 0. Y means when x is less than 2, like this, you see. When x is less than 2, x minus 2 is negative. When x minus 2 is negative, modulus of x minus 2 become minus of x minus 2. That becomes 2 minus x. Now our problem will be reduced to, see, modulus of x minus 1 become x minus 1 plus modulus of x minus 2, now only we got it as 2 minus x is greater than or equal to 4. Now x minus x will cancel, minus 1 plus 2, that become 1 greater than or equal to 4. You are having here is true that this 1 greater than or equal to 4 is wrong, which is absurd. This is never possible. Therefore in this case we don't have any solution. That means x does not belongs to at all 1 comma 2. We don't have any solution, no solution in this case. You have no solution in this case, right? This is what you have no solution in this case. Now see, my dear students, case 3. In case 3 is nothing but we have that the real number line minus infinity to infinity, 1, 2. This is answered, this is answered. Now case 3, this is the interval we are going to take. X belongs to 2 to infinity. That implies x greater than 2, like this, right? Now our interval modulus of x minus 1 become x minus 1 only. Okay, y means, because x minus 1 is positive. Y means when x is greater than 2 means x is greater than 1 already. X is greater than 2 means 2 is greater than 1. That means x is greater than 1. That's why x minus 1 is positive. Next, modulus of x minus 2 is equal to x minus 2 only, because x minus 2 is positive. That means x is greater than 2. Already we know it, because that is what our case here. Now our problem becomes modulus of x minus 1 plus modulus of x minus 2, okay, greater than or equal to 4. This will be reduced to this become x minus 1 plus x minus 2 minus 4 is greater than or equal to 0. Now this is 2x minus 1 minus 2, that become minus 3 minus 4 minus 7 is greater than or equal to 0. That means you have x is 2x is greater than or equal to 7, x is greater than or equal to 7 by 2, like this. That means 3.5. Therefore the solution set is here, my dear students. You have here minus infinity and this is what, plus infinity you have, and in this case you have that 7 by 2 is here, 7 by 2, that equal to 3.5, right? And also our case is x greater than 2, x greater than 2, this is 2 here, okay, x is now, this is what you are having greater than or equal to, here it is included interval, and x is greater than 2 means you have this interval, right? This is open interval. Now the common solution is this, and this is included. Therefore x is greater than or equal to 2 by 2. In this case, therefore, my dear students, x belongs to closed interval 7 by 2 comma plus infinity. This is what the solution set we have got. Okay, my dear students, you please observe how we did this particular problem. In this case, you see, when x belongs to, okay, 2 to infinity, that means when x is greater than 2, x minus 1 become x minus 1 only, because x minus 1 become positive. Why? Means when we know that x greater than 2 means x is greater than 1, that means x minus 1 is positive, then modulus of x minus 1 become x minus 1 and modulus of x minus 2 become x minus 2. That means x minus 2 is positive. That means now you see, my dear students, our problem, a modulus of x minus 1 plus modulus of x minus 2, this become x minus 1 plus x minus 2 minus 4. By simplifying this, we have got x greater than or equal to 7 by 2. Now the common solution is 7 by 2 to infinity. Now overall the problem solution what we have got in first case, we have got the solution set as, in first case we got the solution set as x belongs to minus infinity comma minus 1 by 2, right? Minus 1 by 2. This is what you have got in the first case, and second case there is no solution, and the third case it is 7 by 2 to infinity. This is what the total solution set in for this problem. It is a very, very important problem, my dear students. You please observe. Next we will do one more problem. Now, my dear students, another interesting problem of today's class, and the last problem of today's class, is solve modulus of x minus 1 by x plus 2 less than 1 and x is not equal to minus 2. This is true because if it is equal to minus 2, this becomes 0 denominator, that's why it will not be defined. Okay, now let us proceed to the problem, my dear students. How we will do this particular problem? You take modulus of x minus 1 by, right, x plus 2, you have minus 1 less than 0, like this. Now you take the LCM here. If you take the LCM here, x plus 2 you have here like this. That means modulus of x minus 1 minus x minus 2 less than 0. You have like this, right? Wonderful. Now this problem reduces to modulus of x minus 1 minus x minus 2, right, by x plus 2. You have like this. This is less than 0. Now also in this case, my dear students, we are going to have two cases, right? Because we have here modulus of x minus 1, okay, when it is positive, okay, case 1, when it is negative, how we are going to get, that is what we are going to discuss. Now you see, my dear students, case 1 here, if you take x minus 1 is positive, that means modulus of x minus 1, modulus of x minus 1 is equal to x minus 1, like this. Okay, when x minus 1 is positive, modulus of x minus 1 become x minus 1. Now our problem, this problem will reduces to now modulus of x minus 1 become x minus 1 minus x minus 2 by x plus 2. This is less than 0. This problem now reduces to, see, like this. Now x minus x will cancel, minus 1 minus 2, that become minus 3 by x plus 2 is less than 0, like this. Minus 3 by x plus 2 is less than 0. Now this become, you see, by multiplying by multiplying by right, minus sign, we will get that 3 by x plus 2, 3 by x plus 2 greater than 0. Now dividing by 3 on both sides, what we are going to get, 1 by x plus 2 greater than 0. And you know that, my dear students, if you take the reciprocals to this, what we will get is x plus 2 is less than 0. We are going to get x plus 2, right, minus 3 by x plus 2. Okay, we are going to get like this we are going to have. Now see here in this problem, 1 by x plus 2 greater than 0, my dear students. That means you multiply and divide by x plus 2, x plus 2 by now x plus 2 whole square, that is greater than 0. That means now, my dear students, x plus 2 is greater than 0 into anything becomes 0. X plus 2 is greater than 0 into anything becomes 0. That means you have got x is greater than minus 2, right? X is greater than minus 2. Now you see, my dear students, if you x is greater than minus 2 and x is greater than 1 here, now our common solution you are going to have here minus infinity to plus infinity, here minus 2 and here 1. Already case 1 is x is greater than 1 and x is greater than minus 2. You have like this. Therefore, from that what we are going to have is, right, okay, the first solution x minus 1 greater than or equal to 0 means here it is included. Now this is what the common part, therefore x is greater than or equal to 1 is what the solution in first case we are going to have. That means x belongs to 1 is included because x minus 1 greater than or equal to 0, x belongs to 1 to infinity. This is the way how we will get this particular problem solution, my dear students. Now see case 2, my dear students. In this, x minus 1 less than 0, that means x less than 1. Modulus of x minus 1 become minus of x minus 1 because when x is less than 1, x minus 1 is negative. When x minus 1 is negative, modulus of x minus 1 become minus of x minus 1 because you know that mod x equal to minus x when x is less than 0. Now it become minus x, minus into minus plus 1 and 1 minus x you have got. Now our problem here, this will be now modulus of x minus 1, that becomes, now only we got it as 1 minus x minus 2 by x plus 2 less than 0. Now this become minus 2x minus 1 by x plus 2 is less than 0. Now by multiplying minus sign on both sides, you will get here 2x plus 1 by x plus 2 is greater than 0 like this, right? This is what we have got here. Now we need to solve this. Let us multiply and okay, because this is not a positive quantity, we are not sure about it. That's why we will make it is a perfect square and we will transfer to the right side by the concept of the method of intervals. Now this is multiplying and dividing by x plus 2. Multiplying and divided by x plus 2 whole square. Now this is greater than 0. Now we got that 2x plus 1 into x plus 2, that is greater than 0 into x plus 2 whole square, that is 0 you have got. Now in this case the solution set you are going to have, right? Fine. Okay, minus infinity and plus infinity you have here minus 2 and this is minus 1 by 2 you have, and it is greater than 0 means this part and this part you have here. And already we know that x is less than 1 because this is what case 2, x less than 1, let us take here 1 and x is less than 1 means this is what our solution. And from that, my dear students, you can get that what is our common solution. Here we have here the double line shaded portion we are writing here. Therefore, my dear students, x belongs to minus infinity to minus 2 union minus 1 by 2 to 1 is what the solution set in this case we have got like this, right? Now by combining both solutions, in case 1 and case 2, we will get combining case 1 and case 2, we obtain that the solution set of the given equation is right. Therefore the solution set I am writing here, solution set, okay, like this we have got this, my dear students. Now let us write the total solution set including all the cases, case 1 and case 2. Okay, how we are going to get now case 1 and case 2 including right, the solution set we are going to have is x belongs to minus infinity comma minus 2 union you are going to have minus 1 by 2 to infinity, minus 1 by 2 to infinity. This is what the solution set you are going to have, my dear students. You please observe. And my dear students, we are going to upload very interesting videos in our YouTube channel. You please subscribe for that, such that you will get new videos and you can get them and watch them and improve your knowledge and be successful in your life. Thank you very much. Thank you for watching.